Okay, hello everyone. We are from ECC 3303 Embedded System. Our topic is IoT disaster management. So our project is water dam level control and alert system. We are from group 1. Our members is Anuar, San, myself, NurSarafina and Subaitha. Okay, this is our team's member roles. Myself as a project manager, Hion Yuen San as hardware and software lead. Next is Subaitha Afrin as integration and product lead, and Anuar is a finance manager. So what is flood and dam system? Flood is the most common and widespread natural occurrence of severe weather. A flood is an outpouring of water that submerges from ground. Flash flood are capable of releasing rainfall volume over specific areas, so making detection is remain difficult. Therefore, to improve flood control, a dam system was used. Dam system can control the flow of water from natural source, also used for irrigation and to prevent flooding of area inhabited by humans. So our problem statement is water disruption has become such a problem that when a flood occurs, the water supply become insufficient. The manager also frequently wait too long to make emergency water release during times of heavy rainfall and exceptional river flow. So our solution is by creating IoT dam, water dam level control and alert system. It has a function to monitor the water level. It also sends alert whenever the water level is abnormal or normal. And the IoT system also able to control the dam gate to open and close automatically by measuring the current water level in the dam. So our expected outcome from this project is first to ensure the public safety by using dam water, by using the monitoring and analytics system. Next is notify user about the low water level so that user can practice water rationing. Next, I will pass to Anwar.
Okay, for a little review web article, we found 3 web article. What is a flood? Of course, a flood. A flood through dam for flood control and IoT solution detect floods and minimize risk. From the 3 web article, we found the 3 findings. This is first flow and dam manage perform general maintenance and prevent water flow optimally. And from the IoT solution, the use of the sensor data integrate with user application to inform residents about potential hazards and able to provide necessary resources such as a list evacuation area and personal safe measure. That's for me.
Okay, next, Ivo. Okay, thank you. Okay, for technical papers, we have researched about 5 technical papers. The first one is from Mrs. Schanberg. She has proposed about IoT-based flood monitoring and alerting system to justify the project design, which is to monitor the flood by sensing the water level in riverbeds and check if they are in normal conditions. And the next one is about IoT flood monitoring system, which keeps update on water level through website and alert public whenever the water level is rising. The methodology discuss the compilation of data input and making to public. And the third one is dam water level monitoring and alerting system using IoT, which the study enables the smart alerting method by using IoT-based alerting of dam water level. And the fourth one is flood monitoring and alerting system use the IoT, which based on ARM7 processor and Arduino controller sensors. The author identified the mitigation of by reduce the risk of flood. And the last one is that it describes the concept of IoT, disaster management, and proposed IoT architecture for flood data management, and proposed an IoT architecture implementation that obtains, scan, and handle the flood-related data. I will pass to Anwar.
Okay, for little review from journal, I found this from IEEE portal. First, the SMS flood alert system, and second, design of flooding detection system based on velocity and water level dam with ESP8266. For overall, from journal, we finding a remote water level alarm system is developed using liquid sensor and GSM technology, where the system will observe and monitor the water level remotely, and the water level will determine the extent of the floods as low, medium, or high. This will enhance early flood detections. Okay, thank you.
So for the proposed methodology, These are the system features of water dam level control and alert system. The first feature is constant monitoring of water level, and the other feature is automatic lighting feature. For the first feature, when the water level is high, LCD displays high water level alert and red LED lights on. The gate opens and regulates the water level until it returns to normal water level. When the water level is normal, LCD displays normal water level message, green LED lights on. And when the water level is low, low water level alert message is displayed on LCD and the red LED lights on. SMS will be sent to users. And the extra feature is automatic lighting feature where lights on when low light intensity is detected and the lights off when high light intensity is detected. Next. This is the block diagram of the system. The microcontroller used is Arduino. The input include ultrasonic sensor, Wi-Fi module, LDR sensor, and the outputs include LCD, LED, motor, and SMS. This is the system flowchart. First, when the system is started, the system loops whenever the system is on. Wi-Fi module establish connection. And for the first feature, which is automatic lighting system, LDR sensor detects light. When high light intensity is detected, the light intensity level is calculated, and if the light intensity is low, LED lights up, and if it is high, LED lights off. And for the constant water level monitoring system, ultrasonic sensor measures water level. When the water level is high, LCD displays high water level message, red LED lights up, and the gate opens. If the water level is normal, LCD displays normal water level message, green LED lights up, and the gate is checked whether it is open or not. And if it is open, the gate is closed, and the system loops if the gate is not open. And if the water level is low, LCD displays low water level message, red LED lights up, and SMS is sent to users. Next. For the programming flowchart, similar to the system flowchart, the system loops as long as it is on. Wi-Fi module establish connection, and the light intensity is read from the LDR sensor pin. From here, we assume that the light intensity that is sufficient is 600. And if the light intensity level is less than 600, the value of LED becomes 1, which is turns on. And if it's not sufficient, 0, which is turned off. So for the constant monitoring system, ultrasonic sensor reads water level, and the distance and duration is calculated, and the water level is converted into percentage. Here we assume that when the water level is high, which is above 80%, LED lights up, LCD prints message, and the motor is started where it rotates from 0 to 90 degrees. And if the water level is normal, which is at between 55% to 80%, the green LED lights on, LCD print message, and the motor turns to the original state. If the water level, lastly, if the water level is low, the red LED lights up, LCD prints prints message, and SMS is sent to users. Yes. And that's all for our presentation. Thank you.